Hey, this is Mr. Hansen. This is the second in a series of probability videos. In the last one, we looked at sample space and we used Venn diagrams and tables and tree diagrams to kind of illustrate what the sample space looked like and what all the possibilities were. And we kind of defined what probability is, which is just the chance of your chosen outcome out of the all of the sample space or the total outcomes. So we're going to pick it up from there. I've got a little Venn diagram here, and I wondered if there was a relationship between people who watch basketball and people who play basketball. So this is some data here. This is, to be honest, it's kind of made up, but maybe if I surveyed 100 people, maybe I would get something like this. So let's take a look at this. Notice over in the left-hand corner I have probability of people who watch. That's how you write that, just P with the parentheses and then W, your event, whatever your event is, goes right inside that parentheses. So the probability of people who watch, well, let's see, we consider that whole circle, so you got to go 40 plus 20, that's 60, and then 60 out of the entire thing. So there's people who play right here that weren't included in that, and people who don't play and don't watch. So people who play and don't watch and don't play and don't watch. And so if we added up all of those numbers, I've got 60 plus 30, that's 90, that's 100. So we got 60 over 100, or we have a 60% possibility of in this survey of picking somebody who watches basketball on TV. Okay, let's see. Probability of playing. Take a look at the other circle. You can see 20 plus 30. That's 50% there. So 50 out of 100, or 50% of the people who were surveyed play basketball. Now I've got this next line here. This is the complement of the probability of people who watch. Complement, sometimes it's written with a slash there or a little c, and it means the opposite. So people who do not watch. People who do not watch. And so in this case, the probability of people who watched was 60%. So the people who do not watch, it's going to be that 30 plus 10, it's going to be 40%. Or you could say 1 minus probability of people who watch. 100% minus the 60% is the 40%. So that's how you find the complement of something. It's just the opposite. Remember, you use 100% and subtract what did happen to find what didn't happen. So in this case, it would be 40%. Okay, and finally, this last thing, it's a conditional probability. So the way we would say this is probability of people who watched given that they played. So let's take a look at our Venn diagram. So our sample space now, since it's conditional, is just out of this many people, just out of that many people who watched given that they played. Well, that's 20 out of 50. So 20 out of 50 probability of people who watched given they played. 20 out of 50, and let's convert that to a percent so it's easy to compare. That's going to be 40%. Okay, now I said something about comparing. Let's compare these two things and see if it tells us something interesting. So the probability of picking a person who watched basketball is 60%, and the probability of picking a person who watched basketball given that they played it is 40%. So are people who play more likely or less likely to watch? I want you to think about that for a minute. Are people who play more likely or less likely to watch? Here we have 40%, and here we have 60%. So I would say they're a little less likely to watch based on this survey. And maybe it's because they're busy playing. Maybe that's why they don't watch basketball on TV, because they're busy playing it. Okay, if the number was exactly the same, the 40 and the 60, then these events would be independent events, meaning one really doesn't have an effect on the other. But since they're a little bit different, we can say that that playing has some kind of effect on watching the game. Okay, let's take a look at this one other way. Let's look at it as a table. So I'm going to try and fill in the numbers here. It says watch and play, kind of a joint frequency here. So people who watch and play. People who watch and play is going to be 20. People who watch and don't play is going to be 40. People who watch is going to be 60. Okay. People who don't watch but play is going to be 30. And people who don't watch and don't play, this one outside is going to be 10. And so people who don't watch is 40. And so there's 100 people in all. 50 people don't play, and 50 people do play. Okay, so let's take a look at the probability of watching. That's going to be 60 out of 100. Okay, and then down here, the probability of watching given that you play. So out of all the people that play, who watches? That's going to be 20 out of 50. So these are what we're comparing, the 0.6 to the 20 out of 50, that's 0.4. So that's saying out of this category of people, out of the people who play, fewer watch. There's only 40% compared to out of all the people surveyed, 60% watch. And so this is telling you that playing has some kind of effect on watching basketball. I hope this helped you understand. I really wanted you to kind of get an idea of this notation here that we worked with. I wanted you to see how this idea of conditional events works, how you can find that. So that was 20 out of the whole thing out of 50. And I wanted you to understand what complementary events meant. And I wanted you to be able to compare conditional events to an event without a condition to kind of see if one variable had an effect on the other. So that was the big goal of this video. Thank you for watching. Hope you have a nice day. This is Mr. Hansen signing out.